Welcome back, students. We have been doing algebra and the two polynomials for 10th standard Cbse mathematics. In the previous video, we have defined what is the value of a polynomial at a point and what do we mean by zero of a polynomial. Now we are going to answer the 4 questions in this video. What are they? They are the geometrical representation of a linear polynomial. So how do we represent a linear polynomial geometrically? Okay, and second question is, what is a zero of a linear polynomial? What is a zero of a linear polynomial? What it means geometrically? What it means geometrically? And finally we answer the question how to find the zero of a linear polynomial. And finally we will try to give a general formula to find the zero of a linear polynomial. Okay. Now we will answer one by one. Now what do we do is, let us consider a linear polynomial. Let us consider a linear polynomial. So let us consider a linear polynomial. So what is the first question? The first question that we are going to answer is geometrical representation of a linear polynomial. Okay. Now what is the general form of the linear polynomial? For example, if we consider p of x, if we consider p of x to be a polynomial of the form ax plus b. So for this to be a linear polynomial, we must include the condition on the coefficient a, namely it is not equal to 0. It is not equal to 0. Why do we say that it is a linear polynomial? Because the power of x term is 1. So the power of x term is 1. So this is the general form of a linear polynomial. General linear polynomial. Linear polynomial, because the power highest degree term is here, it is 1, therefore it is a linear polynomial. Now what do we do is, here what are we going to do is, if you want, you can take this polynomial to be y for the sake of convenience, okay, for the sake of convenience. Now what we are going to do is, let us take, see, this is the general polynomial. You can give any value to a, any non-zero value to a, and any value to b. You can give any value to b, where a and b are real numbers. For let us say that a and b are real numbers. And remember that a is not equal to 0. Now what I am going to do is, I am going to consider a to be say, for example, 1. Let us take a to be 1 and b to be 0. Only condition on the linear polynomial is the coefficient of a is not equal to 0, but b can be 0. So what will happen in this case? In this case, the polynomial becomes y is equal to p of x, and that is equal to 1 into x, and 1 into x is nothing but x. So you can take, so y is equal to p of x is equal to x. Y is equal to p of x is equal to x. Okay. Now let us try to draw graph for this. So let us try to draw graph for this equation, okay, or for this polynomial. Okay. So what are we going to do? We are going to draw the graph. Okay. We are going to draw the graph. So let us draw the lines. You can take this to be the y-axis, this to be the y-axis, and this you can take it to be x-axis, this you can take it to be x-axis. Okay. So by taking this as y-axis, so let us call this as x-axis, and if you want you can take either this as y-axis or you can take this to be p of x-axis. So they are one and the same. So what do we have here is, this is what we have. This is what we have. From here we have y is equal to x. So this is what is the equation is. So this is what is the equation is. So polynomial equation now reduces to y is equal to x, or you can write it as p of x is equal to x. In any manner you can write. Now what I will do is I will give values to x. I will give values to x. So I will give values to x. So when x is equal to 0, then y becomes 0. Y becomes 0. So what are the possible values now? X 0, y 0. X 0, y 0. So I will take here value of y to be 0. So this is value of x and this is value of y, pair of values. Okay. And when x is equal to 1, when you substitute x is equal to 1 here, y becomes 1. So y is also becoming 1. Right? When you substitute x is equal to 1 here, what you will get is y is also 1. When you substitute x is equal to 2, you can call this as equation 1. In the equation 1, what the value of y is also going to be 2. And you can give negative values also. You can give negative values also. So when x is equal to minus 1, y is going to be minus 1. So this is what is happening. So what we have done is, either you can take the value of y to be y, or this is p of 1, or this is p of 2, or value of the polynomial at the point 2. This is p of minus 1. So these are all values. Now what are we going to do is, this is x is equal to 1 and this is p of 1 value, or y is equal to 1. And if you take this is x is equal to 2, and if you take by taking 2 units as 2 units of x-axis equal to 1 unit, then if we write this is x is equal to 3 and it is going to be 3, and here x is minus 1. So this is minus 1. Now let us try to plot. So this is 0, 0. This point is 0, 0. Let us plot 0, 0, and let us plot here one by one. Okay, let us plot here one by one. So this is 0, 0, and here it is going to be 1, and it is 2, and it is 3, and here also we can plot 1, 2. Now what will happen? This point is 1, 1. This point is 1, 1, right? So here the value is 1, 1, and then here it is 2, 2, and here it is minus 1, 1. X value is minus 1, y is also minus 1. So next point is 2, 2. So you can keep on give values like this, and the next point is minus 1, 1. Now if you keep giving values for all these things, what you will get is this is what you will get. This is what you will get. So you will get a line. You will get a line passing through these points. Line passing through these points. So this is the line. Okay, this is the line. So this is an equation of straight line. Equation of straight line. So this straight line is represented by the polynomial y. This is the polynomial y is equal to p of x is equal to x. So this is the polynomial. So this is the graph This is the graph or the diagrammatic representation of this polynomial. Diagrammatic representation of this polynomial. Okay, so these are the graphical values: 0, 0, 1, 1, 2, 2, minus 1, 1. Of course, we have taken only the integer values. You can give even fraction also. So this is nothing but half, half. So 1 by 2, 1 by 2, 1 by 2, 1 by 2. You can even give any real number. So what is the moral of the story here? The moral of the story is nothing but any linear polynomial. So that is what we learn. So if y is equal to p of x, and that is equal to ax plus b, comma a is not equal to 0, this linear polynomial, this is a linear polynomial, as you know, because just a little while ago we said that this is a linear polynomial because the degree of the polynomial is 1, represents a straight line, represents a straight line in 2 dimensions. Why I am telling 2 dimensions? That is important because we are drawing the equation of line in a graph sheet in 2 dimensions. So I am including the dimensions also. So it is better to say along with the dimensions. Let us take one more linear equation and see whether that also represents a straight line or not. Okay, let us take one more example and verify whether really it represents, that also represents a straight line. For example, you consider y is equal to, this is the polynomial, p of x is equal to say x plus 1. So this is the polynomial. Okay, because this is also a linear polynomial, and we are going to express this polynomial diagrammatically with the graphical points. Now what do we do is simple, as we did earlier, give values for x. So when x is equal to 0, what will happen? When x is equal to 0, y is equal to, this is p of 0, put x is equal to 0 here in equation 2. Put x is equal to 0 in equation 2, p of 0. So what you will get is 0 plus 1, which is nothing but 1. Now you take the value of x is equal to 0 and y is equal to 1. Now you collect the points. So the set of all points gives you the graph. So this is x value and the corresponding y value from the polynomial, obtained from the polynomial. Okay, obtained from. Now what will happen when x is equal to 1? When you substitute x is equal to 1 here in equation 2, when you substitute here, so I am going to replace x by 1 in equation 2. So what am I going to get is 1 plus 1. 1 plus 1 is 2. So when x is equal to 1, I am getting the value of y is equal to, or p of 1 is equal to 2. So I am getting 1, 2. In a similar manner, I can give x is equal to 2 also. See, I am considering only the integers. If at all necessary, you can give values for fractional values also. So y is going to be, so when x is equal to 2, I am going to replace x by 2 in equation 2. So you replace x, you replace this x by 2. Okay, you replace this x by 2. Okay, so what will happen in that case? So it is going to be 2 plus 1 and it is equal to 3. Now collect the values. So when x is equal to 2, p of 2 is 3 or y is equal to 3. Now let us give negative values. What will happen when x is equal to minus 1? when x is equal to minus 1, y is equal to, when x is equal to minus 1, y is equal to p of minus 1. Replace x by minus 1. So this x by minus 1, I am getting p of minus 1, and you also replace here also by minus 1. Here also by minus 1. So what do you get is minus 1 plus 1 is equal to 0. So what you get here is minus 1 comma 0. Minus 1 comma 0. And you note down this value. This is something special. Let us box these values. Okay. Let us box this value, because as we are going to see something about this particular value. Okay, we will come to that little later. Likewise, you can keep giving values for what? X, and you will get getting corresponding values for what? Y. Okay. Now let us try to draw the graph. Let us try to draw the graph. Let us try to draw the graph of this polynomial, namely y is equal to x plus 1. So what are the points? So this is the graph, that this is y is equal to p of x, and that is equal to x plus 1. X plus 1. And what are the points that we have obtained? Because we are going to draw the graph. So points we have obtained are graph. Graph means collection of all xy points. What are the points that we have obtained? 0, 1, 1, 2, and 2, 3. So these are the points. And minus 1, 0. See, these are the points that we have obtained. So I am collecting all those points, and so on. So it will go like this. So it and so on. Now with the help of these points, this is what is the graph of what? P of x. Graph of p of x. P of x is nothing but x plus 1. P of x is nothing. Now let us try to draw the diagram for this. Let us try to draw the diagram for this. Okay? Diagram for this. So what do we do here? Let us draw the diagram. Okay? So this is what a straight line is. We have drawn a straight line, and we are to draw a horizontal line. Okay, having drawn two straight lines, let us call this as what? X. Let us call this as what? X, and this axis as, either you can call it as y axis or p of x axis. They are one and the same. Now what do we do is, let us get back to the graph. So now we are going to plot these points. These points are obtained from this polynomial equation. So these points are obtained from this polynomial equation by giving different values. That's what we have seen a little while ago. See, when x is equal to 0, we are getting the value as 1. So 0, 1. When x is equal to 1, when you substitute x is equal to 1 here, 1 plus 1 is 2. So when x is equal to 1, y is equal to 2. When x is equal to 2, y becomes 3. So 2, 3. When x is equal to minus 1, y becomes 0. So those points are collected here. We have put that in a set. Okay, we have collected the points, and we are going to plot these points on a graph sheet, on a graph sheet. Okay, now before that, what do we do is, let us mark this is 1, and this is 2, this is 3, this is 4. On x-axis we are marking the points. Likewise on y-axis we are marking the points. So this is 1, this is 2, this is 3, and this is 4, and this is 4. What are the points we have? So this is the origin. So this is the origin. Okay, this point is the origin, 0, 0. Okay, and this point is nothing but minus 1. This point is nothing but minus 1. Now let us plot. Let us take the first point. What is that? 0, 1. So x is 0, y is 1. So this is the point under consideration. So 0 comma 1, so this is the point. So this is 0 comma 1, the first point. Next, what do we have? We have 1 comma 2. When x is equal to 1, y is 2. When x is equal to 1, y is 2. So this is the point. So this is 1 comma 2. We are plotting the points on the graph sheet. This is 2 comma 3. So when x is equal to 2, when x is equal to 2, so when x is equal to 2, y is 3. So this point should come. Okay, let us plot it. So this point should come. So this is when x is equal to 2, this is y is equal to 3. So this is the point under consideration. This is 2 comma 3. Okay, and when x is minus 1, y is 0. When x is minus 1, y is 0. So what are we going? So when x is minus 1, this is the point, y is minus 0. So this is when x is minus 1, y is 0. Okay, so these are the 3 points. These are the 4 points that we have marked. Now what are we going to do is we are going to draw a straight line passing through. We are going to collect all the points. We are going to collect all the points. See, I am going to join all the points. You may ask a question, can we join all the points? Because we have taken only what? The integral values. We have taken only the integer values, but you are joining all the values. Is it correct? Of course it is correct. The reason for that is, as I said earlier, for the sake of convenience, we are drawing what? We have taken only the integer values here for x, but you can take, x can take, remember that, note that x can take any real number. Note that x can take any real number. So any real number. So when x can take any real number, implies y also can take any real number. Y also can take any real number. Any real number. So no problem. So that we can join all the points between these two integers, between 1 and 2. So you can join all the points. Likewise, you can join all the points. So thereby we get a straight line. Again, the moral of the story, I remind you, what is the moral of the story? Moral of the story is the polynomial equation, linear polynomial, namely x plus 1 represents a straight line. So when you try to draw a diagram, when you try to represent it diagrammatically, then this equation represents a straight line, provided when x takes the values on the real number. Provided the x takes on the values on the real number. So this represents a straight line. This is the moral of the story. So now we have answered the first question. Okay, what is the geometrical representation of a linear polynomial? So we can now answer the geometrical representation of a linear polynomial. So whenever you represent a linear polynomial geometrically, then it will be represented by a straight line, provided our x takes on values on the real number system. Okay, now if at all necessary, we can mention here that also. You can mention here x takes value in the real number system R. Okay, in the real number system R, you can mention that. Now what is a zero of a linear polynomial? Now let us try to answer the second question. What do we mean by zero of a linear polynomial? Now we have said that every linear polynomial represents a straight line. Now what is important here is, if you carefully notice the fact that you consider this point now. Now the y becomes 0 if in this equation y becomes 0 only when x is equal to 0. So when you substitute x is equal to 0, you will get y is equal to 0. So this is where, so whenever y becomes 0, whenever in this equation, whenever y becomes 0, that y is nothing but p of x, the value of the polynomial. This is nothing but, okay, let us write here. This is nothing but value of p of x. Value of p of x is equal to x is 0 only when x is equal to 0, meaning when you substitute x is equal to p of 0, you will get 0, and if you take that to be y is 0. That means what? At the point when x is equal to 0, p of 0 is equal to 0, polynomial becomes 0. If you denote the polynomial p of x as y is equal to p of x, then y value becomes 0 when x is equal to 0. That means the straight line meets the x-axis. This means the straight line geometrical meaning is the straight line meets the x-axis, meets or cuts the x-axis, cuts the x-axis at x is equal to 0. So it cuts the x-axis when x is equal to 0. Rather, it cuts the x-axis when x is equal to 0. Cuts the x-axis when x is equal to 0. So when x is equal to 0, or it cuts the x-axis at the point 0, 0. So what is the 0? Geometrical meaning of 0 of a polynomial is the polynomial becomes 0 when x is equal to 0. The polynomial y is equal to p of x is equal to x becomes 0 when x is equal to 0. The geometrical meaning is at that point when x is equal to 0, then only the corresponding straight line meets the x-axis or cuts the x-axis. That means when x is equal to 0, y also becomes 0. So that is the point where, namely, which point? This is the point 0, 0. So 0, 0 is the point where the polynomial meets the x-axis or cuts the x-axis. The diagrammatic representation of the linear polynomial, namely the straight line, cuts the x-axis. Now let us go to the second example. Now we ask the same question here. When this polynomial, so as we said that this is also a linear polynomial and that can be represented diagrammatically like this, right? By this straight line. Now this straight line cuts the x-axis at the address. What is the address at which it cuts the x-axis? The address at which it cuts the x-axis is, this is the address, right? This is the point where it cuts the x-axis. What are the points? When x is equal to minus 1, the polynomial p of minus 1, namely minus 1 plus 1 becomes 0. So that is the 0 of the polynomial. Therefore, x is equal to minus 1 is the 0 of a polynomial. Is the 0 of what? This polynomial, namely p of x is equal to x plus 1. And if you want, you can write this as y. Now, when x is equal to minus 1, the corresponding value of y is, so when x is equal to minus 1, the corresponding value of y is 0. So that is the address. So minus 1, 0 is the point where the straight line, where the straight line represented by the polynomial by the polynomial p of x is equal to x plus 1 cuts the x-axis. So that is the geometrical meaning. So cuts the x-axis. So this is the address where the corresponding straight line cuts the x-axis. So what is the geometrical meaning of 0 of a polynomial? When the polynomial becomes 0, then the straight line representing the polynomial cuts the x-axis. That is what is geometrical meaning. So when we say that a polynomial is 0 at some point, then that point together with the value of x, is what is called the address at which the straight line represented by the linear polynomial cuts the x-axis. So that is the meaning geometrically. 0 of a polynomial is nothing but for 0 of a polynomial, as we said, the value of x for which the polynomial becomes 0 is 0. Geometrical meaning is every linear polynomial is represented by a straight line, and that straight line cutting the x-axis. The point at which it cuts the x-axis is what is called cuts only at the 0 of the polynomial. Now we are going to find out how to find. We are going to develop a procedure how to find the 0 of a linear polynomial. Now let us take an example first. So what do we do is, for example, let us take an example. This is consider a linear polynomial. This is linear because the polynomial is linear. Again I am repeating this. The degree of the polynomial, namely, is 1. So it's a linear polynomial. Now how to find the 0 of this polynomial? The method here is, what do we do is, for what value of x this p of x is equal to 0. So simply what do we do is, you take the polynomial 2x minus 1 and simply equate it to 0 to get the 0 of the polynomial. Now what do we do is, you keep 2x on the left hand side and minus 1, you push minus 1 to the other side. That means using the additive inverse idea. So what I will do is, if you push minus 1 to the other side, you will get plus 1. Okay. Now what will happen? 2 is non-zero. So you can divide both sides by 2, a non-zero number. So which is nothing but the multiplicative inverse idea. So x is equal to 1 by 2. So we have found the value of x. Now you can check whether it is correct or not. So that is the 0 of the polynomial. So what will happen? I am going to replace x by half here. So here also you replace it by half. You can cancel out these two 2's. So what you will get is 1 minus 1, and that is equal to 0. So therefore you can say that x is equal to 1 by 2 is a 0 of the polynomial p of x, that is equal to 2x minus 1. Okay. So this is the 0 of the polynomial. Now and what is the geometrical meaning? And so this is the point 1 by 2 comma 0 is the point at which the straight line. So when you try to draw the graph for this linear polynomial, you will get a straight line. That straight line will meet at which the straight line representing the polynomial, which polynomial? The polynomial that we have mentioned, polynomial p of x is equal to 2x minus 1 cuts the x-axis. So this is the geometrical meaning, cuts the x-axis. So this is the geometrical meaning of the polynomial. So what is the relationship between 0? At the point 0 of the polynomial, the graphical pair 0 comma the corresponding y value is what is called the address at which the straight line representing the polynomial cuts the x-axis. So this is what is the geometrical meaning. Now you look at the polynomial carefully. So we are going to get the general formula. So this is the polynomial, and we have found the 0 to be excuse me, off. Okay. Now what is the coefficient of x here? What is the coefficient of x here? Coefficient of x. Coefficient of x is 2. And what is the constant term? What is the constant term here? Constant term is minus 2. So when you say that constant term, you have to tell along with the sign. So this is minus 2. Now what is the 0 of p of x? 0 of p of x. 0 of p of x is nothing but negative of constant term. So this is the general formula for a linear polynomial. Negative of the constant term divided by coefficient of x. Coefficient of x. So if you remember this, then you will be able to write it. So negative of, so minus. What is the constant term here for us? This is minus 1, and divided by coefficient of x is 2. So which is nothing but 0. This is the 0 of the polynomial. So let us generalize this. So in general, if p of x is equal to ax plus b with a not equal to 0, because if a is equal to 0, then that becomes a constant polynomial. So if a is not equal to 0, then 0 of p of x, 0 of p of x is equal to minus constant term divided by coefficient of x. Coefficient of x, which is nothing but minus constant term by coefficient of x. How do we get this formula? That we will explain here. Okay. That we will explain here. Okay. That we will explain here. How do we get this formula? That we will explain here. Right. See, you take this polynomial. So we are going to find the 0, and we have obtained the formula for 0. Now you take this polynomial. So you take the polynomial ax plus b and put that is equal to 0. Now you push b to the other side, then that will become minus b by the additive inverse idea. Now a is not equal to 0. Remember that a is not equal to 0. That we have mentioned here. A is not equal to 0. See, therefore you can divide it by a. So this is minus b by a. But that is nothing but minus b is nothing but constant term of the polynomial, linear polynomial. So constant term of the linear polynomial divided by coefficient of x. So this is the general formula to find 0 of a linear polynomial. And if you remember this, then you can find the 0 of a linear polynomial at once. Simply by looking at the linear polynomial, you will be able to tell the 0 of a linear polynomial. So with that we stop here, and we will be using this idea. To find the zeros of a quadratic polynomial in the next video. Thank you.